Let us now discuss scalar and vector fields. In calculus, field is actually a coordinate system in either 2D or 3D or n-dimensional system where we can define different functions. A scalar field associates a scalar value to every point in space. A scalar field is defined by a function, a scalar function. The example of a scalar field can be a temperature. Temperature is dependent on a position of a point in space. We need just one variable, a scalar, to define a temperature at a particular point. For example, temperature field of a roof which is subjected to elevated temperature. The roof can be of reinforced concrete. We can define the temperature field as function of x1 and x2 is equal to constant. So in the figure, we can see the temperature function defined along z-axis and x1, x2 as a independent variables. Similarly, we can have a mass of a body defined as a scalar field. So imagine we have got a RC shell structure whose mass is varying. In the figure, we can see a function which is cos x1, cos x2, and this is a mass of a body. So in short, within a scalar field, we should be able to define a function of our interest. Also, we should be able to perform different type of operations within a scalar field. Like if we want to multiply that function with a particular number. So whatever we get, whatever scalar value we get after multiplying a particular number, that should also lie within that field. We should be able to add or subtract different scalar values, and whatever result we get, that should also lie within a scalar field. So a field is actually a coordinate system which defines a certain function. Since we are dealing with vector algebra, we have scalars and vectors. So correspondingly, we can have a scalar field or a vector field. The important thing to appreciate within a field is that they should be able to encompass any function of interest. So a scalar function can have equations of lines, equation of planes, surfaces, and functions of several variables. One should be able to perform different arithmetic operation on those functions, and the resulting functions or the resulting scalar values should also be within the scalar field. Now let's move to vector field. Before going to vector field, let us first discuss a vector space. A scalar space is very straightforward. We have the same three coordinate system, and within that system, different scalar values should exist. And those scalar values can be result of many other scalar operations. The operations can be multiplication, division, and so on and so forth. So that can be a field. But please remember, whatever we are discussing now, those are real value space. We are not talking about imaginary numbers. These are all real number space, and they can be either in 2D or 3D. A vector space is also a space, a coordinate system, which can have different vectors defined at different locations. So in case of scalar field, we had scalars defined in different positions. The vector space should be able to define different vectors. In addition, it should be able to define a group of vectors, their resultants, the addition of different vectors, and multiplication of different vectors. Please remember, the addition of different vectors give us another vector, and that vector should also be defined by the vector space. In addition, a vector space has got some other properties also, such as if a particular vector is within that space, so the negative of that vector should also be within that space. 0, a null vector, should also be part of that space, so on and so forth. So we are trying to define a coordinate system which can accommodate variety of vectors. And if we add group of vectors, whatever resulted we get, that should also be defined by that particular vector space. Similarly, if we multiply scalars with vectors, whatever vector we get, that should also be defined by our vector space. The vector space also accommodates scalars. So if we take dot product of some vectors, we get a scalar. That vector space should also define a scalar. Now let's come to vector field. So just like a scalar field, in a vector field, every point is associated with a vector. That vector is defined by a vector function. So it's similar to a scalar field. A scalar field has got just one magnitude, just one value, a scalar value at a particular point. In the case of vector field, it has got magnitude plus a direction. So there is a vector at every point within a field. So for example, in the figure, we can see different tangents which are shown as vectors. So this is also a vector field. This is a vector field corresponding to tangent of curve. So for example, this might be a vector field corresponding to velocities. These might be velocity vectors. In a similar way, we can have a vector field which contains normals to the field. This can be a shell structure having normal at different location, and that makes a field. All these vectors, they make a field. So a vector within a vector field will have a direction and will have a certain magnitude. Sometime the vector might be of such a big magnitude that we will have to normalize all the vectors within vector field so that everything is accommodated in one space. So we scale the vectors down in order to accommodate it within our space. A vector field can be in 2D setting, in 3D setting, such as this one shown. So it is important to note that vectors in the vector field can be all of same magnitude or they might be of variable magnitude. The vectors in the vector field gives us some idea about a pattern. Like for example, within this box, there are many vectors and we can see that as the distance from the origin increases, the vector magnitude reduces. As we move towards the origin, the vector magnitude increases. This can be acceleration or velocity vectors, and which at a particular point within a body might be very high and away from that point might be very low. If vectors are made up of normals or unit vectors, then they might all be of same magnitude. Vector field is made up of different points and every point has got a vector. Every vector would have three components.